Hi guys, welcome back. So in this lecture, I'd like to talk to you a little bit about processing. So processing is a language that allows you basically to control your Arduino in two different ways. One is interaction, second one is full remote control. Today I'm going to cover interaction. The idea with interaction is that you've got a sketch running on your Arduino which is sending results of its readings from sensors and so on via its serial port. It could be Bluetooth or serial of some kind to a computer. On the computer you've got a processing sketch that takes those readings and does something with them. In my example here, what I'm doing is I'm taking readings from my Arduino and I am putting them into this user interface. So up here I've got my temperature and humidity readings in numbers, and I've got these two visualized as bars down here. I also have, here's the circuit I'll be showing you later. Let's say press this button. You can see that the state of the button can also be transmitted and sent over to the processing sketch on my computer, so I can do something with it and visualize it. And there's also a little potentiometer. I've got the pink bar that changes accordingly as I am changing the value of the potentiometer. So that's the first way of using processing. The second way of using processing is, as I said, full remote control. So I have you could install a small program Sketch on your Arduino, which is there as an agent of my processing sketch. All processing is happening inside the processing sketch, which sends its instructions to the sketch running on the Arduino, so that the Arduino controls its the space and devices around it. So if you go to the Arduino website, click the playground and check out the processing page, it talks a lot about the second method of using processing, and that requires the installation of a sketch called firm data onto your Arduino. There's instructions on how to do that, but that's not what I'm talking about today. Before going into showing you the two programs, one the processing and one the Arduino Sketch, just wanted to show you another little example of what you can do with firm data. So if you go to r2.io, which is a platform that I talked about in my podcast last week, you can see that R2 is a platform that allows you to use a single language, Ruby, to control multiple Internet of Things platforms. One of those platforms is Arduino. So if I have a look inside here, you'll see that the way by which your Ruby script controls your Arduino is by first installing the firm data. So you need to have firm data uploaded and installed onto the Arduino so that your Ruby script can interface with that sketch. A little background about processing. So processing was conceived back in 2001. Its objective was basically to make it easy for people that are not necessarily programmers to do visualization on computers, and that visualization can be things like through 2D or 3D graphics, create PDF output documents as OpenGL, and many other things. All of those things basically have to do with visualization. And a great repository of examples of what you can do with processing is here. So you go to openprocessing.org. There are it allows you to browse lots of different examples. So just pick to one, and you can see that this one allows you to create a little graphic game, could call, I suppose, a demo. It follows your mouse cursor and just draws something on the screen. And there's lots of other interesting things that you can see here that other people have done. You can execute all the inside the browser as well, so nothing else to do. Okay, so yeah, that's quite nice. So okay, so now let's go ahead and have a look at how this little gadget works and how you can interface your Arduino to your computer. So this is not supposed to be a detailed presentation of processing and what it can do and how it works, but it's a preview, so I want to show you the basics. So first thing to do is to go to the processing website, that's at processing.org, and download it. So the download page, can make a donation if you so wish. It's always a good idea to help out projects like this. Then download the installer for your operating system and just double click on it. The process is very similar to the installation of the Arduino IDE, since both really are based on the same kind of platform. You can see that the IDEs are very similar. So I'll let you go through this on your own. Next, your best friend is the reference, a language reference. So there's two places that I'd like to highlight. First one is the language reference itself, where you can see all the important keywords. For example, we'll be doing a lot of two-dimensional printing today, so we'll be using things like a rectangle here, rect. There is fill, so this one here that allows you to fill in a shape like a rectangle. You can see that it takes either an integer that represents a color or like a full RGB value like that. And then you can, whatever follows, whatever geometric shape follows the fill statement, it will just take the color that you specified in the fill statement. So that's, there's a few more keywords here that I'm going to show you in the actual processing sketch in a minute. Next, I want to show you libraries. The one library that we'll be using in my example is the serial library. It allows you to interact with devices connected to an RS-232 or compatible serial port, like the USB port that we'll be using. And you can see here that this is how you initialize the object. This is the example here, where you provided a name of the serial port. It goes here, and then the speed of communication, and that's how you can write something out the serial port. You can use the write method in it. Of course, if you wanted to read something from it, then you can use the read method. I'm going to again show you an example of that. So a couple of other interesting things, like you can interact with video cameras, for example, capture a video stream. Networking is also available, and PDF exporting, and so many other really interesting things. So with that done, next thing I want to show you is the processing sketch that I'll be using in the demo. I want to highlight a few commands first and the general setup of the processing sketch. So don't worry about fully understanding how the sketch works and how it interacts with the Arduino Sketch. And I just want you to get a basic understanding of the structure of a processing sketch. You'll see it's actually very similar to what you are used to in the Arduino. So we start by importing the libraries that we need. In this case, it's the serial library for the communication. We initialize the serial object, we call it my port. We use that to communicate with the USB device, the Arduino in our case. And then we've got a setup method, very similar to the setup method in the Arduino Sketch. Right. So the first thing we do is to set the size of the processing window. So you see 250 by 400 pixels. That's the dimension of this window here. That will provide our output. Next line down, we initialize the my port object. So we pass the location of the device, the serial device that we'll be using. I'll show you a little bit later how to get this information for your own operating system, and the speed of communication. Now here it says, this is interesting, it says it sets the character that the serial interface should be looking for before it calls a special method that will then process whatever text the sketch has received through the serial port. So what happens is that the serial port will receive characters, and then once it hits this character here, in this case it's the new line, it's going to go and call this method here, serial event, and then inside serial event we're going to process the text that was received. Right, so this is like event-driven programming. So back to the serial event a bit later to see what's in it. Finally, in this setup example, we just set the color of the background. I set it to 0, which represents black, so you can see that the background in my processing window is black. The second important method here, next to setup, is draw. So draw is pretty much the same thing as loop. As soon as the processing sketch completes executing the setup method, then draw is going to be called. And draw is going to be called again and again and again in a loop until you finish with the program. So inside draw you can put whatever you want your processing sketch to do. In this case we are testing for key presses and then reacting based on what these keys are that the user presses. So anything that you want to be done continuously inside a loop, automatically executed, you put it inside draw. One thing to remember is that just like with the loop function in Arduino, same thing with the draw function, you should never call it explicitly. So the framework is going to call draw whenever it can, essentially. Okay, next item I want to talk about is how to figure out the name of your USB device. So if you are on a Mac or a Linux computer, then your serial device is going to be inside your dev directory. So on the Mac, for example, I just go and have a look inside the dev directory, dev, and look for a device that has a file name that starts with USB. So I could have multiple ones, but in this case I've only got one, so I'm a bit lucky. So that is the name of the device that my Arduino is connected to. So I'm going to copy that and put it inside my initializer for my serial object right here. Okay, so next thing to consider is in my setup now I have an Arduino and I've got my computer running the processing sketch, and I want them to interact. The Arduino is going to be getting readings from its sensors, especially the DH22, but I've got a rotary potentiometer here and a button. So I wanted to collect values from these three things and then send them off to the processing sketch. Further, I've got an LED here, and I'd like the processing sketch to instruct the Arduino to turn the LED on and off. So if I press the A button, for example, I'd like the LED to go on, and if I press the B button, I'd like the LED to go off. You can choose what buttons you'd like to press. So I've got both ways communication, Arduino to computer and computer to Arduino. An easy way to get data from the Arduino to the processing sketch is to just put it in a comma delimited string. So what I'd like to be able to do is to have value A followed by value B followed by value C with a comma, and then with a println I'm going to insert a new line. So the processing sketch is going to capture this text, right? And then it's going to work through the delimiters and extract the values so that it can do further processing on them. On the way back, I'm just sending a single value. So that single value will instruct the Arduino to turn the LED on or off. So probably the easiest way to get started is with the Arduino Sketch, since we are all familiar with that. What I've got here is a DHT library, I define that the DHT pin being number 2, so it's the type of my device, and then initialize the object. We've seen this before. I set the LED pin and the button pin, and define 2 floating point numbers for the humidity and the temperature. Then I use the last reading, which grabs a value out of millis, so that I only read the DHT sensor every 10 seconds. Right, because the DHT sensor is kind of slow, so I don't want to stress it too much. So that's what I do in the loop here. Right, I wait for 10 seconds to elapse, it's 10,000 milliseconds, and then grab a reading by just calling this function down here. Right, so yeah, we've seen this before. One thing that I forgot to mention is that I'm setting the speed of the serial interface to 38,400 bits per second, which is the same as the speed that I set in my processing sketch for my serial port. So these two speeds, of course, have to match. Then once I get my readings, I go and start constructing my comma delimited string. So I start with the temperature, insert a comma, then print out the humidity. Notice that there's no length here because I don't want to break the string yet. And I grab, I read the serial port for any incoming characters, and if it happens that it receives an A, then I turn the LED on. If it receives a B, either uppercase or lowercase, it turns the LED off. Then I put in another comma, read the value in analog pin 0, which is the one that the potentiometer is connected to. Another comma, and finally get the reading from the button. It's going to be a 1 or a 0, and end it all with a print ln, so that inserts the final line feed. Of course, my sketch is not really optimal, so I should probably move this bit up to here. So it just makes a bit more sense to have all the printing done in one go and then deal with the button pressed and the LED. Right, so I'm going to go ahead and upload this sketch now. Oh, you can see that it's complaining that the serial port is already in use, and that's because my processing sketch is using it. So I'm going to close that window to release the port and try to upload again. It's taking a little bit too long. So what I'll do is I'll disconnect and reconnect my Arduino. Double check that I've got the correct port selected. It looks alright, and then try to upload again. Okay, done uploading. It's good. Let's move on to the processing sketch. So as I explained earlier, we've got the serial ports. It seems like I've got them included or imported twice, so I'm just going to remove the first one. Go through my setup and set the dimensions of the window. We now understand what the buffer until function does. Set the background. Now repeatedly inside the draw function, I'm checking to see whether a key has been pressed. So as long as there is, as long as the processing window has the focus, it can listen to events that happen by typing on the keyboard. So every time that I hit a button on the keyboard that triggers an event, it's a key. So that event represents the key press. So inside the key pressed variable, I can check to see whether the key is a particular kind. Either it's A lowercase or A uppercase. And if it's either one of these two, I'm going to start drawing. So the fill command in this case allows me to define the color that that any geometric object that I'm going to draw next is going to have. So in this case, I'm defining black. So RGB value 000 is black. So what I'm doing here is I'm creating a rectangle where its top corner, its top left corner, is at position X0 and Y60, and it's got a width of 249 pixels and a height of 25 pixels. And that's how you define a rectangle. And I'm going to my serial port and I'm writing out a character A, capital A. So this character is captured in my Arduino Sketch right right here. So with my serial.read method on the Arduino side, I'm capturing the letter that my port.write sent off through the serial port, and then I can process it and turn on the LED. Then here I'm creating a new color that's going to be orange, a shade of orange. I am defining the size of the text I'm about to write at 18 points, and then I'm writing this text, LED on, at position X10 and Y80. This printout comes out in the console, so down here, we'll see that in a minute. I'm doing the exact same thing here, but now I'm capturing the B key in case that was pressed. Right, I'm just blackening that area, that rectangular box first, so that this cleans out any previous text. And writing the B in the serial port, creating a new color, and then setting the size of the text to be 18, and then writing the text LED off at the same position as we had LED on. Right, and inside the serial event, remember this event is called when the incoming text from the Arduino sends out a new line feed. So that triggers an event. It's a serial event. We go and grab the string that was sent from the Arduino, and hopefully it's not null, so we're checking for null strings, although this is probably a little bit unneeded, because if we have a null string then this event is not going to be called, but it's just in case. But anyway, I'm trimming off the incoming string just in case it's got any white characters. Again, probably because I'm controlling the Arduino, I know that it's not possible for any white space to be sent over, so again I'm being a little bit paranoid here. But it's quite useful. I'm splitting the comma delimited string into tokens, and each token then goes into its cell in a string, in an array of strings. Here we're converting the values from the array of strings into numbers that we can use later on to create the bars and the representations in the user interface. Here we've got mappings, so exactly the same map command from the Arduino IDE. It allows you to take a number that you know is in a particular range and translate it into a new range. We do that for the XY, which is the humidity and the temperature, and the value of the potentiometer. Down here we are creating the bars for the bar representation of these values. So first we blacken the area that will contain the bar graphs. The stroke command, we use it to define the color of the border of a shape. So for example, you see down here that I'm using the rectangular function to create a rectangle, and the stroke for that is going to be this color, which is kind of orange again. Down here I create a rectangle which is going to be tall in accordance to the value X from the map up there. The higher the temperature, the longer this bar is going to be. And I do the same thing for the humidity. So the higher the humidity, the taller the bar is going to be. In the next block, I create some text output. So go up and define the, so again I erase the contents of this area. In this area is where I'm going to have the text written. So at the very top of the window, set the size, and then print out this text at this location, and then again that value at this location. Finally, if the button is being pressed, then I'm going to print out a message, and if it's not pressed, I'm going to print out this message, button not pressed. So finally, let's execute it and make sure that it works. Right, there we go, starting up. Its temperature and humidity zeros, waiting for the first input from the Arduino. Let's wait for a second. Okay, there you go. So the Arduino sent off the data, and it does so every 10 seconds. So let's see, I'll press A and the LED goes on. B, the LED goes off. Then I'll press the button. So the button pressed. Turn the potentiometer, and the potentiometer bar moves up and down. So hopefully you find this introduction to processing interesting, and think about the kind of projects that you could implement with processing as part of your system. At the very least, you could use it to create user interfaces like that for your projects, for your monitoring stations, etc. As always, any questions, feel free to ask.